Okay, on exercise 10, we're supposed to identify any errors, and then once we find an error, we need to state what the correct thing should be. So the first thing that I see are the hypotheses are about the sample proportion. I guess I highlighted that a little too much. All right, so we'll try that a little bit lighter. Okay, so the null hypothesis says that the sample proportion is equal to 0.9. We're not going to hypothesize about that. We know that the sample proportion is whatever 657 divided by 750 is, which turns out to be 876, right? 87.6. So what it should be is that just P equals 0.9 and P less than 0.9. So as we look at the rest of it, they're looking at the conditions. We have a simple random sample, that's what SRS stands for. Here's an issue, so they're calling attention to the fact that the sample size is bigger than 10, which we really don't care about. We want to know that we can expect at least 10 successes and 10 failures from samples of this size. So this number, what we should be looking for is we want to be able to expect that 0.9 of 750 is bigger than 10, and that 0.1, right, which would be our failures in this case, so 10% of 750 is also greater than 10. So that's another issue, and that's what we should have there. We should also note that we have independence, so the amount of milk that one adult drinks is independent from the amount of milk that another adult drinks. And then finally, our fourth condition that hasn't been talked about here is the sample needs to be less than 10% of the population. So we have 750 adults that were in our sample, and it says we have this multi-county area. So hopefully there's more than 7,500 adults living in the area. And then that would kind of clean up all of our conditions section. Okay, the next bit where they have a mistake, they have the sample proportion here, 657 over 750, and that's all correct. And then they're talking about the standard deviation of sample proportions, and the issue is they're using the sample proportion there. Well, we're building a model based off of the null hypothesis being true. So we'd be expecting to have 0.9 for our sample proportion, right, on average. And then that would leave us with 1 minus 0.9, or 0.1, as the other number in our numerator. And so then when we multiply, we're actually going to get 0.011 as opposed to 0.012. So the number itself isn't that big of a difference, but the numbers that are used actually makes the issue, which leads us to this issue, right, based off of this other number now. So this should be 0.011, and then so now we're going to get a different z-score of negative 2.18 instead of just negative 2. Okay, so we have a z-score of negative 2.18. There's actually a few different errors in their final bit, their conclusion. Okay, so first off, we're concerned with the alternative hypothesis of the proportion being less than 0.9, as is stated up there. So we'd actually be looking for z-scores less than some number. And like we talked about, our z-score is not negative 2 anymore, it's negative 2.18. Okay, so that's definitely not the correct p-value. Right? So the proportion of z-scores less than negative 2.18 is definitely not 0.977. So looking at our z-table, we'd find our negative 2.1 row and then come over to the 0.08 column. And that's the probability of it obtaining a z-score less than negative 2.18, which is what we're looking for our conclusion. So our p-value is going to be 0.0146. Right, so there's that mistake fixed. And then even if they had the correct percent here, there'd still be an issue with their sentence. So I'm going to go ahead and erase this to start with, and really just this, the sentence is wrong. So we could put something along the lines of 1.46%, but it's still wrong. So it's not that there's a 1.46% that the stated percentage is correct for this region. It's if the null hypothesis is true, right? So if the proportion of milk drinkers is really 90%, and I'll just state it rather than write it all over the screen, then we could expect to get a sample proportion like we got, right, which is 87.6%, or smaller, about 1.46% of the time. So that's the correct interpretation of p-value. If the null hypothesis is true, we can expect to get a sample statistic as extreme as we got, or more extreme, about whatever this percent of the time is, right? That's where our p-value is coming from. So I hope this helps on number 10. Remember, math is cool, and so are you.